All right, so there's two pieces, there's two elements to a function. So we have a number or a piece that goes into our function, and we call that the input. So when we have our function notation, where we have an S in front of something in parentheses, whatever's in parentheses, that's the input. So we're going to go ahead and label that. And then whatever happens, whatever the function is doing to that number, whatever number comes out is the output. And sometimes you've probably seen this before in your schooling textbooks or teachers think about function machines as a way to describe what's happening. So it's kind of this idea of like a number is going into the machine. The machine is doing something to the number, like maybe it's going to like add 2 to the number, and then whatever the result is, whatever that number that comes out, that's the output. So that would be a really basic function rule, something like f of x equals x plus 2. The number that goes in, add 2, and you get a number that comes out. All right, we saw this earlier in the year that we have functions represented in different ways. So you could have the inputs and the outputs organized in a table, a graph, or an equation. And so what we're going to look at here is how do we evaluate a function depending on the form that it's been presented to us. So first of all, let's do some labeling on our table. So I'd like you to go ahead and label the first column. These are the inputs. So the inputs are what we would call it the set of all the x values. And then the next column over, I'd like you to label this. Those are the outputs. So the output is like the f of x column. It's also like the y value. If you think about this being on a graph, we know that f of x is interchangeable with y. We've done that a few times. So here's how we evaluate it. So the first example here, if we want to find f of 7, that means when the input is 7, what is the output? So we are just going to look on our table, and I'm going to circle this piece at the very bottom because that's where I have an input of 7, and I can see that the output is 12. So I want you to go ahead and try on your paper, I want you to fill in what is f of 1 using that table. Okay, Megan, what did you get for f of 1?
0.
0. Beautiful. When the input is 1, the output is 0. Okay, the last question is the opposite question. So let's see how it's worded a little differently. It says, for what x value does f of x equal negative 2? So now it's giving us the output. It's saying the output is negative 2. We want to work backwards and find the input. So the only difference is that now we're going to look for negative 2 on the right-hand side where the outputs are, and then we're going to look backwards and see what the input was. So let me erase that green. It's sort of covering it up. So that's going to be this piece right here. So notice that when the output is negative 2, that's when we had an x value of 0. So the 0 in green is a different 0 than the 0 that we have here in red. It was a different question that we were answering. Okay, so that's when we can deal with functions from a table. Next, from a graph, we're going to start again with some labeling. So we always put our inputs on the x-axis. So let's go ahead and label input on the x-axis, and then it's the outputs that go on the y-axis. If you have room on the top, that's where I would probably like to write. I don't think I have room. I'm just going to put it here down below. That's where the outputs go. All right, so same questions. Our way of answering them is just going to be a little different now because now we're looking at a graph. So for the first one, to find g of negative 2, that's finding the output when the input is negative 2. So I'm going to go on the input axis, which is the x-axis. Right here, I'm going to find the x value of negative 2. And I'm either going to go up or down wherever the line is for that x value. In this case, it's down below the x-axis, so I'm going to go down here to this point. And then I'm going to go over here and I'm going to look at the y-axis and see, okay, that y value, the corresponding y value, is negative 1. In other words, when the input is negative 2, the output was negative 1. That's just an ordered pair that's on the graph of that line. Then we have the opposite question. So here we want to find for what x value does g of x equal -3. So remember here, this part, that g of x, that's the output, and we're looking for an x value, so we're looking for an input. If we can wrap our head around what part is the input, what's the output, that can help us to know what piece we're trying to answer. So the output of -3 means we have a y value of -3. So we're going to be looking down here on the y-axis. The y value of -3 here. I'm either going to go to the left or the right to find the line. In this case, I'm going to the left. And then this point here in green, so that's when we had an output of -3. And look at this. Look how that worked out. We're going to go up to where the inputs are, the x-axis, and we see that we also have an input value of -3. And that's just that point on the graph was -3, -3. When the output was -3, so is the input. All right, the final way that we can represent and work with functions is from an equation. So here we're just using h, which is another common letter here. H of x is equal to 3x minus 4. This is the one that I think most closely connects with the function machine that we drew over here. So if x is the input, what happens to it is it gets multiplied by 3, and then we subtract 4. And then whatever the result is, like that's the number that comes out of the machine at the bottom. So if we want to find, like, h of 5, all we're going to do here is we're going to plug in x equals 5. It means we have an input of 5. We're trying to figure out what the output is. So I'm going to write it like this. H of 5 equals 3 times 5 minus 4. We could do a little order of operations here. So it's going to be like 3 minus 4, and that answer is 11. The next one is really similar. If we want to find h of -1, we're just going to plug in x equals -1. It's going to be 3 times -1 minus 4. It's really -3 minus 4, and that equals -7. All right, now we can also go backwards for the equation here. So for what x value does h of x equal 26? Well, now it's saying h of x, the output, is 26. If the answer was 26, what was the x value that caused that to happen? So notice that now we're not plugging 26 in for x. We're plugging 26 in for, like, the answer part. That's the output. We're working backwards, and we're going to solve this equation for x. We're going to figure out what was the input. So we're going to solve the equation like we normally would. We can add 4 to both sides. Let's divide both sides by 3. And we end up getting that x equals 10. So that's what the original input would have been. If you test it going the other direction, if you plug 10 into the equation, 3 times 10 is 30, subtract 4, sure enough, you get 26. Pretty good. All right, so let's just check off our work here on the back side. So I'm trying to do a little color coding here. So everything in blue, that was a question about the g function. And g of x was given to us here in the table. So I went ahead and circled the ordered pairs, the values that we were looking at. We didn't have any questions on this side where we had to work backwards. All of our situations were given an input, and we just needed to figure out the output. So the input is always like the x value, that's the first column of our table, and then the output is just like the corresponding y value. So that was the number in the second column from our table. So that's how we got the -5 from this point. When x is 9, we got 14, and then when x is 0, we got 7. So that takes care of those blue questions that we're all utilizing the table. Let's look at the red questions here. So the red ones are all the h questions, and that was using the function 2x plus 1. Here we're just plugging in the number that they gave us in parentheses. We're just plugging that in for x, and then we're using order of operations to simplify that down. And I circled the final answer that we should have gotten for each of those different inputs. And then finally, the green questions here, these were all the F questions. So these are based on the graph. And so we wanted to find The number in parentheses is the x value. So for example, when we're doing f of 3, we're looking for like an x value of 3. We're going up to the graph, and the answer there, the output, that's the value of f of 3. So that's how we ended up getting 4, is like what y value corresponds with that x value. We got that f of 7 is 2, and we got that f of 1 is also 2. And I have those points highlighted here as well.